This question is from GATE 2014 Mechanical Engineering Paper Set 1, question number 40. A 200 millimeters long stress-free rod at room temperature is held between two immovable rigid walls. The temperature of the rod is uniformly raised by 250 degrees Celsius. If the Young's modulus and coefficient of thermal expansion are 200 gigapascal and 1 into 10 to the power minus 5 per degree Celsius, respectively, the magnitude of longitudinal stress in megapascal developed in the rod is dash. Let's write the given things. First thing that is given is the length. Length is 200 millimeters. It is stress-free at the initial condition at room temperature, but it is held between two immovable rigid walls. So, if we look at it like this, we can say these are the rigid walls between which the rod is held, something like this. Initially, stress in the rod is 0. There are no internal stresses. Now temperature is being uniformly raised to 250 degrees Celsius. That means change in temperature delta T is 250 degrees Celsius. Now temperature is being raised by 250 degrees Celsius. That means delta T change in temperature is 250 degrees Celsius. If the Young's modulus E is 200 gigapascal and alpha, that is coefficient of thermal expansion, is given to be 10 to the power minus 5 per degree Celsius respectively, we need to find out the longitudinal stress developed in the rod. That means we have to find the stress in length direction. We can write it sigma L is the unknown. Let's see how it is found. Now because the rod is being placed between two immovable rigid walls, when the temperature increases, the rod will expand, and when it tries to push these walls, there will be strain generated in the material of this rod. That strain can be calculated as sigma is equal to change in length upon original length. Change in length here can be given as alpha into delta T, which will be for unit length, into the total length, again divided by L. So strain due to change in temperature is alpha into delta T. Let's substitute and find this out. Alpha is 10 to the power minus 5 and delta T is 250. Therefore strain is 2.5 into 10 to the power minus 3. We know the strain. We can find out stress using Hooke's law. Stress in longitudinal direction will be equal to E Young's modulus into strain in longitudinal direction. This stress would have been 0 if there was no resistance to the expansion. But because this rod is placed between two rigid walls, the expansion of the rod or the change in length in this direction is being resisted by the walls. And therefore the stress is non-zero. We'll find it out using Hooke's law. So this will be equal to E is 200 gigapascal. Let's convert it to megapascal. So we have 200 into 10 to the power 3 megapascal into 2.5 into 10 to the power minus 3. So this simply gives 500 megapascal. The magnitude of longitudinal stress is 500 megapascal. To learn more about strain and stress, you can refer to the NPTEL video Analysis of Strain 4 from the course lecture series on Strength of Materials. This course is by Professor S.K. Bhattacharya of Department of Civil Engineering from IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.